Hey YouTube, Sokyo here, and look at your thumbnail right now. It might not seem like much, but every single second of every single minute of every single hour of every single day, 600 billion neutrinos from the sun pass through just your fingernail, through just your thumbnail to be more specific though. These particles, you cannot detect them through any visual means using the naked eye or any of your senses, but they reveal a lot about our universe and are very interesting. Neutrinos are. I mean, if you were to get a scale of the largest thing in the universe being the universe itself, and then below it would be something like the Great Herculean Boreal Wall, and the smallest thing possible in the universe is the Planck length on this side, the second smallest thing in the universe would be the neutrino, just for scale. Even though it's technically a quintillion times larger than the Planck length, that's still incredibly tiny compared to even something like a proton or a neutron. But anyway, what are neutrinos? Well, there are these tiny particles that are formed through two main methods. The first one is nuclear fusion, where protons are smashed together. This creates a positively charged particle called deuterium, and a type of neutrino as a result as well. There are actually three types of neutrinos: the electron neutrino, the muon neutrino, and the tau neutrino. And radioactive decay is the second way that they are formed, and this is where a neutrino is released as a result of a neutron breaking down. And these particles are released all the time because the sun is undergoing fusion as we speak. It's keeping us warm, even if it's nighttime where I am residing currently. And neutrinos, you can't really stop them. And because, as I said, they're so incredibly tiny, they barely even interact with anything. And that's why you don't feel 600 billion neutrinos passing through your thumbnail every single second. A weird thing about neutrinos as well was that they kind of violate the standard model of physics, which is the accepted ideas about how our universe works. This is because the standard model of physics assumes that neutrinos have zero mass. But that can't be true, because neutrinos, they basically change between the three different types of that I explained earlier: muon, electron, and tau. They somehow are able to change between these different types, and to do that they need to have mass, even though it says that they shouldn't have mass. So that's a bit of a contradiction. And the cosmic background radiation is radiation released from around 380,000 years after our universe began, and it gives us insights into how our universe began. And there's the same thing with neutrinos, but neutrinos from the cosmic background, just neutrinos, if we detect them, they can give us insights into what our universe was like 1 second after it formed.